Okay, here's what I noticed. So you gotta work on being able to tell if something's linear or non-linear when you're looking at their equations. So basically, remember how we talked about like y equals mx plus b is slope y-intercept form, and then this is standard form. So basically you'll see linear equations in those two forms, but really the key is that linear equations are going to be degree 1, meaning they won't have an exponent on x that's higher than a 1. So you can see, oops, I'm just going to change to red. So for example, say you had y equals 3x plus 2. See how the x doesn't have an exponent on it? Or if it does, it's like a 1. So that means it's a degree 1. So you know it's linear. Y equals 2x minus 5. Y equals negative a half x plus 1. Those are all linear. There's no exponent on the x or the y. And you could also see it in standard form. So like 3x plus 2y minus 11 equals 0. That's still linear. You could see a version of standard form where maybe they'd go like 5x plus 2y equals 10. So they could have it situated like that too. So all of these things are linear. They're all degree 1, meaning the x only has an exponent of 1. There's nothing weird about the y. It's also just like an exponent of 1. And there's no weird like, other trig or square roots or anything weird. So those are all linear. So basically, something that's not linear, excuse me, it's going to have something else going on. So it could be like y equals 3x squared plus 5. Well, now your x is squared. So that's no longer a degree 1. That's a degree 2, and it's not going to be linear. So things like that. So basically, yeah, you just want your equations to look like somewhat like these guys. Okay, so that's one piece of feedback. Okay, let's see, what else did you do? Determining slope from, okay, yeah, so then determining slope from different representations of linear relations. So if you have an equation, let's say you have 3x plus 2y equals 5, and you want to figure out what the equation is. Basically, it would be nice if it was like y equals mx plus b. Like this form is nice because you're able to easily tell that the slope is m. So the slope is the coefficient in front of the x. So you really want to just rearrange this equation into slope-intercept form. So what I'm going to do is I'm going to subtract a 3x from both sides, because whatever I do to one side, I have to do to the other side. And I'm subtracting 3x because 3x take away 3x is going to be 0. So that's going to go away completely, and I'll just be left with the 2y on the left. And then on the other side, I'll have a 5 minus 3x. So it's looking a little closer to this. I'm going to rearrange the order of the right side. So I'm going to say 2y equals negative 3x plus 5. Because now it's like in the correct order. The x is first, then the numbers. And when you're moving things around, the sign in front of the term has to stay with it. So the negative 3x stays together, and 5 is positive. You can assume it's positive if it has no sign in front of it. So that's what that looks like. And then I want to isolate y. So to get rid of this 2, since it's 2 times y, to get rid of it, I'm going to have to divide each term by 2. It's a bit of an ugly looking one. But now I know 2 divided by 2 will just be 1y. And then I'll have negative 3 over 2x plus 5 over 2. And now if I want to find the slope, I know it's just the coefficient in front of x. So now I know my slope, or my rate of change, is negative 3 over 2. So that's how you would find slope from an equation. You would just make it look like slope intercept form, and then it's easy to tell. If I wanted to find slope from a graph, so if I had a graph, I think like the one we just did on our test was, I had a different scale. So you have to pay attention to your scales. So say my scale went up by 5s. And my y-axis went up by maybe 10s. because that could happen. And then maybe my equation starts at 20, 30, 40. Okay, so say that was the equation and I wanted to find the slope of it. So I would do that by selecting 2 points on my graph, any 2 points I want. So say I picked those two, and I would make myself a little triangle, and I would determine what is the rise and what is the run. Because I know the slope is equal to the rise over the run. So my rise here would be from 20 to 40. So I know my rise would actually be 20. Okay, sorry, I just had to pause that for a sec. So anyways, like I was saying, rise over run. So the rise is 20, and the run would go from 0 all the way over to 10. So that means the run would be 10. So the slope would be 20 divided by 10, and if we simplified that to lowest terms, it would be 2. Okay, so that's how you find it from a graph. And then also, you could find it from a table of values if you needed to. So from a table of values, let's just say you had just x and y in your table. And let's say x's are like 0, 2, 4, 6, 8. And let's say our y's are -3. Actually, let's do 5, 3, 1, -1, -3. So if you're trying to find the slope from a table of values, you know how we do first differences and we check and see what our y values are going up or down by? So from 5 to 3, it looks like we're going down 2. From 3 to 1, looks like we're also going down 2. From 1 to -1, going down 2. From -1 to -3, we're going down 2. So our first differences indicate that this is a linear relationship. They're all going down by 2. And if we want to use first differences to find the slope, we just count this value as the run, and the change in the x values is the rise. Oh my gosh, just kidding. Sorry. We count this as the rise because that's our y values, right? And our y values, these are our y values, so they would tell us the run, or the rise. Oh my gosh, I'm having a rough day here. And the x values would tell us our run. So our x values are actually going up by 2 every time. So they're increasing by 2. So if we had to determine the slope from this table of values, the slope would be rise divided by run. And the rise is -2, and the run is 2. So -2 divided by 2 would just be -1. So that's how you find the slope from a table, a graph, and an equation. So I would say like that's one thing that you could work on. Being able to find it from different things, and even being able to also find the y-intercept. So I showed you how to find the slope using different representations, but you should also be able to find the y-intercept. So from an equation, it's easy. The y-intercept's just the number on its own here. So 5/2 or 2.5. From a graph, it's the point that goes through the y-axis. So if that's your y-axis, then the y-intercept here would be 20. And from a table of values, the y-intercept is going to be the value that corresponds with x being 0. So our y-intercept is going to be 5. And if you can't see that value on a table of values, you want to use the pattern to help you try to find that. So that was like the main things. And let me just see if I wrote any feedback for booklet 2. Oh, for booklet 2, just some tips would be for example, if you wanted to calculate the volume of something, let's take a square-based pyramid, for example. So say you had a square-based pyramid like this, or what I'm drawing. It's not bad. Okay, so the base is a square, so that means all these sides are exactly the same length. So let's just say our base was 12 meters. So that means each side is 12 meters. And for the formula for the volume is, for a pyramid, is always the area of the base times the height. So the area of the base is going to be base times base, like length times width, which would be base squared, times height. And then if it's a pyramid, we divide by 3. So that would be the formula that's on your formula sheet. So the tricky part for the pyramid is that you need the height. So you need the distance from the top to like the middle of the pyramid. So you need that height right there. And often they'll just give you the slant height, which is like the height, you know, from the top to the side. So usually we call that the slant height. But you need the height from the middle to the middle of the base. Like how tall your pyramid is, you don't need the slant height. So if you're ever given the slant height, then you can just use Pythagorean theorem to help you figure out the actual height of your pyramid. But since this is where the 90 degree is, the slant height would actually be your hypotenuse, your longest side. So if someone gave you your slant height and told you your slant height was like 15 meters, you'd have to do a little bit of work. So you know that this side right here would be 6. And then you'd have to use Pythagorean theorem. So we'd say height squared would equal the slant height squared minus the bottom squared. So you'd have to minus in your Pythagorean theorem since you're finding one of the shorter sides. Okay, so we do 15 squared, which is 225, minus 6 squared, which is 36. And that's 189. And then we would square root that. Okay, sorry, I just need a calculator because I don't know the square root of 189. Okay, square root would be 13.7. So the height would be 13.7 once we square rooted that. So now we know the height. So when we're doing the volume of the square base pyramid, we do base squared, so 12 squared, which is 144, times the height, 13.7, divided by 3. So I think like the 12 squared part you missed. Divided by 3, and whatever the answer to that is. So let's see, 144 times 13.7 is 1,972.8 divided by 3. So the volume would be 657.6 meters cubed. So yeah, I guess just for these formulas, just paying attention to like what each measurement means. So the base, B, just means the measure of one side of the base. So when we square the base, we're doing length times width. We're just doing base times base, 12 times 12. And then the height is always like the height of how tall of it is. So if they tell you the slant height, then you'd have to use a version of the Pythagorean theorem to help you figure out the height. So yeah, that's my last tip.